Hello everyone, I'm Charles Guillemet, I'm CTO at Ledger, and my talk is I'm going to talk about the challenge of digital asset custody. A quick word about me. My background is about security and cryptography. I worked in this industry for more than 10 years, and I joined Ledger 2 years ago when I created the Dungeon. You probably heard about us. This is the internal security team at Ledger, and their mission is to improve the security of Ledger products. And as a security expert, I can say that the best way to have a secure product is to try to break them, and this is what they do day to day. They try to break our product, and when they find vulnerabilities, they worked with the design team to improve the security of the product. They also worked on raising the bar for security in the ecosystem, and we worked on evaluating some other hardware wallets and so on. And we helped the other vendor to improve the security, basically. Then my mission changed a bit, and now I'm in charge of security, engineering, and infrastructure. So let's start. I'm going to talk about the digital asset custody and the associated threat model. Then I'm going to give an overview of existing technologies. And finally, I will talk about the Ledger technology, Ledger secure hardware technology, and how we use this technology to enable digital asset custody. The primary role of a digital asset custodian is to mitigate the operational risk inherent to transaction on blockchain. Blockchain is a fantastic technology, but in terms of security, it pushes the security to the end user, and also you cannot revert transactions. So the problem of security in blockchain is higher than on any other application. And when you are a custodian, you have two main challenges. The first one is to secure assets at rest. Basically, you just have to perform the safekeeping of private keys. And also, you have to tackle the challenge of securing assets in transit, meaning that enforce strong governance workflows for securing transactions. Today, custodians use this kind of scheme, hot and cold wallet scheme. When I say hot and cold, I'm not talking about online, offline, or powered on or powered off. This is more about how they use the wallet. On the cold wallet, they put the large majority of their assets, and there is a very low transaction volume. And they want to have a way to ensure that the cold wallet can only transfer assets to the hot wallet. And on the hot wallet, they use a hot wallet for liquidity management, so there are a large volume of transaction. They also use programmatic interaction. They want everything to be kind of automated. And they also implement automated controls flow. And on the cold wallet side, they often rely on physical access and processes, human processes, and they often want to combine multiple approvals, whitelist, all this kind of governance. So, associated to the digital asset custody are operational threats. The threat can be divided in three main categories. There is first the wallet security, the malicious insider threat, and also phishing attacks. When you design a wallet, there are plenty of things which can go wrong. It's quite difficult. You have to take care of the cryptography and software security implementation. A tiny mistake can lead to the loss of all the funds. You probably know a nonce reuse attack and this kind of vulnerability. Also, when you generate keys, having a high-quality random number generator is very important. Otherwise, you might have some problem. You also might want to use a secure enclave. When I say secure enclave, you want to have something very secure on which you put your keys, and your keys never leave this device. Also, you probably want to have strong guarantees on the genuineness of your wallet, and also about the integrity of the code running on this wallet. I mentioned the case of Trinity. They didn't check the integrity of the code running on their wallet, and they was using third-party code. This third-party code has been malwared, and then the attacker had an access to all the wallets of IOTA users. Also, you might want to take into account the threat of an attacker having a physical access, and having everything, putting everything together makes the task of designing a wallet quite difficult. Also, there are phishing attacks. In this case, it's more about the security on the client side, how the credentials of the clients are secure. As a user, when I make a transaction, how can I be sure that I'm signing what I think I'm about to sign? How can I be sure the amount I'm signing is the right one? How can I be sure the recipient and the receiving address have not been swapped? So what kind of guarantees do I have on what I am signing? And the last class of threat is the most difficult to mitigate. They concern insider threat. As a custodian, how can I mitigate the risk of a malicious insider inside my organization? It's a very difficult task. How do I mitigate the fat finger error? I wanted to send 100 Ethereum and I wrote 1,000. How do I mitigate the risk of a malicious developer of the wallet? The threats are more organizational, I would say, but very difficult to take into account. Now I'm going to give an overview of current the custody technologies and what are the pros and the cons of each of them. So as I said before, we can divide the usage on cold storage and hot storage. On the cold storage, there are several solutions. You probably have heard about the Glacier protocol. So Glacier protocol is a famous way to do cold storage for your asset. On the pros side, it's open source and it's always disconnected from the internet. On the drawback side, it's very complicated to set up and maintain. And as a security expert, I can say that complexity is the enemy of security. It's always a bad way to have a complex security solution. Also, the security is only based on physical segregation processes. You have to use USB stick, hardware wallet, and Faraday cage. And it's not very convenient. And when security is not convenient, users find a way to bypass the security to get better usage, and it's not good for security. It's slow to perform transaction. You need to be close to your device for approving transaction and so on. For cold wallet, also we see a lot of financial institutions which use hardware wallet for their cold wallet. On the pros side, it can be very cold. You can put all your assets in an NOS and put your NOS in a physical vault in the Swiss mountain. So in this case, it's very cold. You also have the trusted display. What you see is what you sign, and it mitigates the phishing attacks, so it's a good property. And you also have intrinsic resistance in the sense that if you give your NOS to an attacker, it's going to be very difficult to extract the keys which are inside. But this is not true for whole hardware wallet, I would say. On the cons side, you don't have any governance. You will have human processes to manage your asset, and it's very retail-oriented. It's not designed for a financial institution. If we look at hot wallet solution, in order to implement governance, you can use on-chain multi-signature. It's great because it removes the single point of failure. It's not possible for a single user to manage the funds of the organization, so it's a good property. But another drawback is there is very few governance. You only have the multi-approval, but it's only a small part of the solution. You still need some whitelisting and this kind of feature. And also, it's blockchain dependent. You have PSBT for Bitcoin, you have the smart contract for Ethereum, and on any kind of blockchain, you will have another solution, and it's not very scalable. To solve this issue, some company developed an MPC-based wallet for hot wallet. Again, it removes the single point of failure. A single user cannot access to all the funds. And it brings some cryptographic guarantees. And in this case, it's blockchain agnostic. MPC threshold signature only depends on the signature scheme. If you have a SecP 256 K1, or even if you have an ECDSA threshold signature, you can use it for any blockchain using ECDSA, basically. So for this, it's blockchain agnostic. But on the cons side, again, it's only a small part of the solution. You still don't have whitelisting and so on, and you don't have a trusted display neither. And it's not you don't mitigate the risk of phishing attacks. Also, the current solutions are very synchronous. They require multiple rounds of interactive communication, and sometimes it's not very convenient. So it's very hot in the sense that it's very online. And also, they are very strong. When you read the paper, there are very strong assumptions on the participant of the threshold signature. You must have a public infrastructure, and you must be able to establish secure channel between participants, between each party, and having a reliable broadcast channel. And in practice, it's never met. A current MPC-based solution does not, as far as I know, implement this kind of PKI. And in terms of security, I would say that the solution didn't pass the test of time. And cryptography is hard. Implementing it is also very hard. And when you want to have guarantees in security, especially for cryptography, you need to pass the test of time. Today, we can see several companies building security solutions based on MPC, and they are implementing articles which have been published 1 year ago. And from my perspective, it's a huge risk. On the hot wallet side, there is also some exchanges. For instance, implement custom platforms. They have a very tailored solution, very well fitted for their particular need. A drawback could be it's very costly. Implementing a hot wallet, a secure hot wallet, is a full-time job, and it's very difficult. On the security side, it depends on the implementation, of course. It's often very software-based. Sometimes they use some kind of secure enclave, but the enclaves are not all equal. If you use SGX or Trust Zone, it's difficult to have a secure solution. There are multiple attacks on them. And also, they often rely on human processes, and it's not ideal. Now I'm going to give an overview of Ledger secure hardware technology, how we use hardware to build our product. Ledger is a security company, and to be very synthetic, I would say that we leverage hardware security to build a security solution. And in particular, we use secure element and HSM. And we have designed a secure channel to communicate between secure element and HSM. A secure element is a chip dedicated for security. It has a very small attack surface. This is the same chip that we can find in smart card, if you saw the talk before. It's designed to provide an intrinsic resistance against an attacker, meaning that you can give a secure element to an attacker and it's going to be very, very difficult to extract the secret which are inside. And also, it's a well-organized industry. They organize security certification process. For a secure element to get this kind of certification, they have to go through a third-party security evaluation by an audited lab. And this is very costly, and it takes several months. And at the end of this process, if everything is okay, if there is no more vulnerability, everything has been patched and so on, the lab issue a report, and an independent third-party certification body will give a certificate. This kind of secret is used in banking card and passport, and when you have to manage secret on the field, this is the best way to do that. On the other side, we use HSM, as I said. HSM stands for Hardware Security Module. This is a physical computing device. It often comes as a PCI card or a network appliance. It contains a crypto processor and anti-tampering countermeasure. Basically, it's a secure enclave that we can use to store and process sensitive data. It can compute cryptographic operation. It can generate keys, and as it's an enclave, the keys never leave the device, and you can use it to sign transaction or anything. In most cases, HSM use PKCS 11 interface, but as it does not fit with our needs, we completely disable this interface, and we use it more as a secure enclave and not as an HSM in the traditional way it's defined. It's used in many applications, all the public key infrastructure, in banking, telecom. Basically, when you do an HTTPS request, there is somewhere an HSM which will sign your challenge. When you do a transaction with your banking card, there is an online call. Somewhere in the world, there is an HSM which will verify the signature of your card. So, HSM are widely used in the security industry, and they are used as a root of trust. On our secure element and on our HSM, we have designed our operating system. We use a native open platform, and we can load third-party code. We can load application on the secure element and script on the HSM. Both targets are very different, but our operating system offers a similar set of APIs. Most of these APIs are cryptographic related. And we can use this API to design a secure channel protocol. And secure channel protocol is a way to communicate from the secure element to the HSM. And it's a secure way to do that. When I say secure, I mean three different properties. The first one is authentication. Authentication means that the secure element is able to prove to the HSM it's a genuine one. To do that, when we manufacture our device, the secure element will generate a pair of keys, and the public part of the keys will be signed by our HSM, and it's this is called an attestation, and we put the attestation in the secure element. And as the secure element is a secure enclave on which it's very difficult to extract secret, you have a cryptographic proof that the secure element is a genuine one. And we have the symmetric mechanism for the HSM to prove to the secure element it's a genuine one. When you have an authentication mechanism, you are able to perform an elliptic curve Diffie-Hellman. This is a famous protocol for key exchange. And when you have a shared secret, you can have the second security property, which is confidentiality. So we have end-to-end encryption from the secure element to the HSM using this confidentiality property. And the last security property is integrity. We use some cryptographic mechanism, which is called MAC, to be sure that the message sent from one side to the other have not been tampered by an attacker. We use this technology on our hardware wallet. You know the NanoS. The security properties are very convenient because when you buy your hardware wallet, you have a way to be sure that it's a genuine one, because the hardware wallet is able to create a secure channel to the HSM. And so it's impossible to counterfeit an NanoS or an NanoX. We also use this secure channel for the firmware upgrade. So we use again the secure channel to upgrade the firmware of the device. And also we use the secure channel for the application management. In the case of NanoS, the secure element is inside the device and the OS as well. And you can load your own application like Ethereum or SSH and so on. And I'm going to explain how we use the exact same technology to enable digital asset custody. This is called Ledger Vault. Ledger Vault is a digital asset management platform. It enables custodians to build their own security solution and to manage their fund. And when I said managing fund, there's two properties. The first one is to safe keep the private keys. So the keys are in an enclave, and they never leave the enclave. So we use our HSM implementation for safekeeping the private keys and to generate keys securely. We also have an audited cryptographic stack. And we also use this mechanism to mitigate the threat of digital asset management, providing a way to our customer to build a governance layer. So our customer can segregate the role in their organization. They have shared owners, administrator, and operators. And the administrator can give some rights to the operators. Maybe they will say that this specific group of operators can access to this very wallet. And if they want to make a transaction, they can do a transaction of 100 Bitcoin a day with multi-approval to 3 out of 5 and only to this address, and so on. All this kind of governance is possible with this security solution, and this governance layer is implemented directly in the secure enclave. So as I said, we use HSM and secure element. On the HSM side, we implemented all the application logic directly in the HSM. The cryptographic stack is implemented in the HSM. Everything blockchain related. When the transaction is actually signed, it's signed by the HSM. But also, the governance layer is implemented directly in this secure enclave. We have a cryptographic isolation of scripts, and also we have a way to prove that the devices are genuine and the code has not been tampered. It's ensured by cryptography. Our HSM also embeds attestation so that we can be sure that the HSM to which we are talking to is a genuine one. And also to mitigate the risk of the insiders in the developer side, we have a multi-signature mechanism to upgrade our HSM. We also have limited the attack surface, removing the PKCS11 interface, and the main interface to discuss with the HSM is the secure channel. On the other side, we have the secure element. The secure element is used for different things. So we provide to the users, operator, and administrator a personal security device. In this security device, there is a secure element, and it's used to generate high-quality random, and also to provide a secure display. So you have a way to be sure that what you see is what you sign. And it can be used for approvals and administration. Again, there is a very reduced attack surface. A secure element has very few interfaces. And again, we have a cryptographic way to prove the device are genuine and the code has not been altered. Again, the same technology as the NanoS. The secure channel is mounted from the HSM to the PSD, and we use the secure channel to authenticate a device and thus to authenticate users. So we have secure approvals using this secure channel. And also we use the secure channel for the confidentiality of the communication. All the data in transit between secure element and HSM is cryptographically secure. To conclude, we built the Ledger Vault using the same technology we built on the hardware wallet. And it enables a custodian to have in the same platform the cold wallet and hot wallet management. They can put the majority of assets on the cold wallet and implement whitelisting and all the governance to enable only transaction for cold wallet to the hot wallet, and on the hot wallet side, they can implement less governance and allow automatic transaction and so on using APIs. On the security property side, we have the secure display. What you see is what you sign. It's very important. We also have the trusted execution, which mitigates the risk of spoofing and phishing, and it allows to implement a flexible governance layer inside the secure enclave. The secure enclave also gives guarantees on the confidentiality of the keys. Again, there is this cryptographic authentication, which allows the user to authenticate using their PSD and not only credentials. And finally, we have the genuineness of devices and integrity of code running on this enclave, which is, again, a very important property. It mitigates the threat of having a malware directly inside the wallet. And finally, our customers have full control because even Ledger has no access to the fund of the customer because all the data of the customers are encrypted inside our solution using the customer's keys, basically. This is the end of my presentation. If you have a question, I will be happy to answer them.
Thank you very much. Hands up. Questions? No one?
Time for lunch.
No, we've got 2 more after this. Right, well, second round of applause then.
Thank you.
Can we get our next speaker up here, please?